Yeah. Hello everybody. My name is Marko Bartscherer. I'm a principal engineer at Intel. I'm leading the OCP data center diagnostics and debug workstream. I'm here with my colleague Enrico, and we are going to present what we're doing in the workstream, and we're really excited about it. I'm going to kind of start with the problem statement. And like giving the last couple of days, I don't even feel I have to talk about it, right? The complexity of our systems is growing and growing and growing more, right? Meta called it ludicrous scale. We have, more and more facing a reality, right? We have data centers that are built up of diverse nodes that are made up of diverse and complex components coming from multiple vendors. I've kind of got this really colorful chart here, kind of showing some example nodes of, made up of components from like 5 different suppliers, put together by the 6th supplier, deployed by an OCP, and we have a tenant that on top of it that actually runs the workload. So that's all highly complex. And really, as an industry, we're lacking a way to, in a unified way, extracting that debug data and performing the debug operations. Many of our suppliers have solved the problem with various successes in proprietary ways, but we don't have a unified method. And as we are getting more and more complex, we don't believe that's sustainable. So we really started this workstream to address and tackle that problem. And this is kind of my vision of the end state, really, is that we would end up with standardized debug interfaces and protocols that allow us, through standardized tools, debug a system that is, that really colorful, diverse node with one set of tools. It's the same tool for a remote debug scenario as well as a closed chassis debug scenario. Of course, the underlying payloads are always going to be different, right? Let's say in both an AMD and a CPU, GPU, you're going to extract registers to register dumps to analyze, or logs to analyze deep problems. We're never going to standardize what's in those dumps, but we want to standardize how we get them out of the system, how we get them efficiently out of the system, and then through like a plug-and-style infrastructure, we will be able to get them quickly analyzed, and as a collective, getting to the bottom of things. And I'm going to hand it over to Enrico.
Hey, thanks, Marko. Okay, so what you can see here on this slide is kind of 3 key pieces to our charter. And we'll get into each one. I think some of these diagrams are a little small. But before I go in there, I wanted to mention, and I think we've heard that throughout the day, this work stream will be working with the other work streams. We need to know what they're doing because some of that stuff will feed into ours. And we'll be looking at what else is happening in the industry and where we can take advantage of those items. Okay, so let's get into each of these. So the first one here, this one is about standardization. Okay, so we're looking at different protocols, different architectures, different interfaces, APIs, what I call kind of containers and pipes for that data. Okay, so we're trying to look at how you transfer the information, not necessarily what is being transferred, right? That's kind of some of the value add from each of the vendors. But we're trying to find a way to make sure that there's a standard way of bringing that information out, okay? This diagram here is showing a few examples, things like USB, going out manageability, and things like that. These are kind of some standard pipes that people have been using. So again, we're just trying to bring things that maybe are already existing, things that are out there, and saying, hey, let's converge on doing that. Okay? So on the second piece of the charter is around effective architectures. Okay? And so there's not a one-size-fits-all. Right? In the data, you can see here in the diagram, the data, there's lots of different types of data. In each of these stacks or columns here in the diagram are different types of data. There's streaming data, there's console, lots of different types of data for diagnostics and debug. And so what we're trying to do is look at that and figure out how to best bring all of those together and communicate that information out. So what you see here is the top is all the different sources. You bring it down through, you kind of aggregate that, and then you bring it out your different interfaces like I mentioned from the previous slide. Now we're going to be focusing kind of in the middle. That's the important piece where we can get convergence. Okay. Let's see. So the last one is about scalability. Now when we talk about scalability here, it's how we use those different pipes and containers, if you will, throughout the life cycle. And we kind of have a diagram here of our life cycle, starting here on the left where you're doing your validation, putting it together, all the way as you go through, all the way over to the right where the product is deployed in field and such. Now, as you probably know, there are different types of debug and diagnostics, different things that you're looking at, different modes that you may have as you progress. And what you really want to do is you want to make sure that you have something that's scalable across that, where you're not having one way of doing it or one way of collecting it for a particular piece of that life cycle. You want something that can scale through that. And you want that to be able to adjust as you move forward through that life cycle. Okay? All right, I'm going to turn it back over to Marko on the call to action.
Yeah. So really, as I mentioned in the beginning, right? I got kind of here our little stack of participants, right? From, what's sort of at the bottom, at the top, right, is us as Intel as a silicon provider, or one of the silicon providers, right? As we said, we're going to probably have systems. And what's really happening in reality, our OEM partners will take ingredients from many silicon providers and put them together to build the nodes that then, our CSPs will deploy, and the tenants run the workloads on top of it. And it all gets pulled together by the tools providers, right? And we really encourage and want to invite really participation from all these layers, because for us to solve this as a solution for all of us, we have to all participate. So yeah, really everybody, it's an open work stream. Please join us. Just going to give a mini plug. We're still looking for a second chair beside myself. So if you're interested, contact me. We are meeting every week on Thursday, 11 PST. Here are all the links to subscribe and find us. So yeah, thanks for your time. And
let's thank our speakers. We have time for a couple of questions.
This is Hari here from Microsoft. So is this forum is making an assumption, what is a data center? Because the word data center is no longer normalized. So it is actually, so the first thing is before we go in, because you're making a lot of assumption about everything egressing out from a platform. Mm-hmm. It is consumed in the same way, and it's consumed in the priorities or the stack or the assumption called rack. Mm-hmm. I could say that may not be true for all orchestrations. So is there a framework you're going to lay out what a data center is and how this fits within?
I haven't thought about it that way, to be honest. So I'll invite you to partner with me to do that.
That was a good answer.
Thanks.
Still in the terminology phase.
Okay, we have time for one more.
So while this is, my name is Dixon from Google. While this talks about debug and diagnostics at a higher level, is there any details being thought about for the different components within? Let's take, if you say, take a server alone, CPU, PCIe, DIMM, DRAM, all those interfaces have their own ways in which they do stuff. So how would that all encompass into this? Is there some thought about that already?
Yeah, so my dream, I would call it the dream because I have a kind of a pretty strong gut feeling that this is not going to happen, that we not quite can pull this off. But in my dream scenario, we would find a way to map all the debug capabilities that are needed into standard manageability constructs, like PLDM files, for example, to pick on one that a lot of stuff fits into, right? Again, that's kind of my dream. My expectation is that, or my optimistic expectation is that we can probably do that for 80% of the problems, and I would be super happy when if that happens. And we have to then work out the rest, but really that's kind of our, the approach we're taking, right? That's, we already have, the BMC is the door into the node. We have established management protocols to get data through that door, so to say, right? BMCs know how to read PLDM objects. The higher layers understand how to deal with the redfish interfaces. The more we can map into that, the better we're going to be off. So that's kind of our approach.
One other thing I'll add is some of the people that are in the work stream, we're noticing that some other components actually have things that they've already been doing. So we're taking a survey of what's out there. And as I mentioned in the beginning of when I was speaking, we have to look at all of the other pieces and really try to see if we can kind of converge, or you may even look at it as taking the best elements of all of these different components and bringing it together. But we are looking at that and not ignoring it and not saying, oh, we're just going to shove it down everybody's throat. We're taking survey of what's out there. So hopefully, yeah, we answered your question.
All right, thanks. I think at this point, let's thank our speakers again, Marko and Enrico.